Hello guys, let's continue with the nomenclature. In the previous video, we have started seeing some of the rules and we saw how to name branched chain alkanes. So in today's video, we'll continue the same. So before we start here, I want you to just recall the previously taught part by watching the previous video so that you will have the continuity. So the next rule in naming the branched chain alkanes is naming same alkyl groups at different positions. Now look at this example. When the same alkyl group occurs more than once on the parent chain at different positions, like this. Look at this. This is the parent chain and these three are the substituents. So we have three substituents and all the three substituents are methyl group. So when the same alkyl group occurs more than once on the parent chain at different positions, the positional number of each alkyl group is separated by commas and suitable prefixes like di, tri, tetra are attached to the name of the alkyl group. So we have 5 carbon atoms in the parent chain. So what would be the root word? It is pentane. In the second position, I have 2 methyl groups. In the fourth position, I have 1 methyl group. So you have to mention this 2 twice. 2 comma 2 comma 4 trimethyl, because I have 3 methyl groups. Trimethyl pentane is the IUPAC name. In the previous video, I told you when you have two different substituents like methyl and ethyl, we'll go with the alphabetical order. While looking at the alphabetical order, the prefixes di, tri are not considered. We are not deciding the alphabetical order of the alkyl groups by taking this into consideration. Only the name of the alkyl group like ethyl, methyl should be considered for the alphabetical order. This tri, di, tetra should not be taken into account. Now look at this example. We have a compound like this. So 1, 2, 3, 4, 5, 6 carbon atoms. I can number from this side also. 1, 2, 3, 4, 5, 6. So if I number from this side, third position for ethyl group and third position for one methyl group. So 1, 2, 3, 4, 5. Fifth position for another methyl group. So when you look at the set of locants, it's getting bigger numbers. So we have to prefer this way of counting. So if you count this way, one methyl group is getting the second position and an ethyl group is getting the fourth position, another methyl group fourth position. So we are preferring this way of numbering. So now while naming, I told you in alphabetical order. So ethyl comes first. 4 ethyl, 2 comma 4, because in 2 and 4 we have the same alkyl group. So 2 comma 4 dimethyl, because 2 methyl groups, dimethyl hexane. Mostly children make a mistake here. What they do is, here we have seen 3 alkyl groups. So we have written all the numbers together, 2, 2, 4 trimethyl. The reason why we have written the numbers continuously is all the 3 are the same alkyl groups, methyl group. But here we have different groups. So we have to differentiate that groups by mentioning the number and the particular name. Here, look here, we have ethyl in the first group, the fourth position. So 4 ethyl and then methyl 2 methyl groups that you can put together because both are same. 2 comma 4 dimethyl. You should not write 4 2 4 ethyl dimethyl hexane. That's not right. First mention the one alkyl group as per the alphabetical order and the position of that alkyl group and then the position of the next alkyl group. If these two are different, then you have to mention again, go with the alphabetical order, write one substituent and then write the number and then the other substituent. Since both are same, we are writing the number continuously. 2, 4 dimethyl, 2 methyl groups, hexane because 6 carbon atoms. Let's look at one more example. Look here, C carbon, CH3, 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 CH3. So one carbon atom is bonded to 4 methyl group. Now choose the longest chain. You can count this way, 1, 2, 3 or 1, 2, 3 or 1, 2, 3. Anyways, you're getting the same number of carbons in the parent chain and the same substituents. So we'll go with the straight one. 1, 2, 3. 3 carbon atoms, propane. In the second position, I have 2 methyl groups, one CH3 above and one CH3 below. So 2, 2, because in the second position itself we have the methyl group. So then also you have to mention the 2 twice. Don't just write 2 and dimethyl. No, even if it is on the same position, you have to put the number twice. 2 comma 2 dimethyl propane is the IUPAC name. Let's see one more example. Now look here, you have CH3, CH2, C, CH2, CH3, and here you have CH2, CH3, again here CH2, CH3. So what is the first rule? Choose the longest continuous chain as the parent chain. So you can number anyway. See, 1, 2, 3, 4, 5. That way also you're getting 2 ethyl groups as the substituent. 1, 2, 3, 4, 5. Then also you're getting 2 ethyl groups as the substituent. So anyways, you can number. So if we get the same substituents while numbering, you always prefer the straight one because it is easier. So choose this as the parent chain. You have 1, 2, 3, 4, 5 carbon atoms. In the third position, you have 2 substituents, ethyl group. CH2, CH3 is ethyl. Again, one more ethyl. So 5 carbon atoms, pentane. In third position, 2 ethyl groups. So 3, 3 diethyl pentane is the IUPAC name. So remember, when the same alkyl group occurs more than once on the parent chain at different positions, the positional number of each alkyl group should be mentioned, and the prefixes like di, tri, tetra should be attached to the name of the alkyl group. And one more thing you have to remember, the prefixes di, tri and tetra are not considered while deciding the alphabetical order of the alkyl groups. Now let's see the next rule. The next rule is about numbering the complex substituent. So far we have seen substituents like methyl, ethyl, and they are very simple. So now we are going to see how to number and name the compound with complex substituent. Now look at this example. See, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon atoms in this chain. Now let me try from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm getting 10 carbon atoms. So I'm choosing this as the parent chain. So if I choose this as the parent chain, then I have 1, 2, 3 substituents here. See? So now this is the parent chain. So if this is the parent chain, what substituents I have? I have 1 substituent here and 2 more substituents here. So totally I have 3 substituents. And these 2 substituents are methyl groups and they are very simple. My other substituent is a little complex. So these 2 substituents are simple. My other substituent is complex. So now how to name such substituents? In case the substituent on the parent chain is complex, which means it is branched. Here it is not branched, but this substituent itself is branched. Then it is named as a substituent alkyl group by numbering the carbon atom of this group attached to the parent chain as 1. So when you look at this substituent, which carbon atom is linked to the parent chain? This carbon atom. So you have to start numbering from here as 1. So you have to follow the same set of rules how you name an organic compound and number this separately and name it and then attach it with the parent name. So you have to number this carbon of the substituent which is attached to the parent chain as 1. So the name of such a substituent is always enclosed in a bracket to avoid confusion with the numbers of the parent chain. Now we will try to name this compound. So now the first question is how to number the parent chain. If I start from here, 1, 2, 3, 4, 5. This substituent gets the 5th position, 6, 7, 8, 9. So these 2 substituents get the 8th and 9th position. So it's better to number from this side so that you get the lowest set of locants. So I'm going to number from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the proper way of numbering. Now in the second position and third position, I have 2 methyl groups. So how can I name them? 2, 3 dimethyl. 2, 3 dimethyl. And in the 6th position, 6. What do I have? Suppose if I have a ethyl group, I would have written 2, 3 dimethyl, 6 ethyl. And then since I have 10 carbon atoms in the parent chain, it is decane. But here I have a complex substituent. So now we are going to number the substituent separately and name it. So let's start numbering from here. 1, 2, 3. 3 carbon atoms, propane. In the second position, I have methyl. So I can call this as 2-methyl propane if it is separate. If this is given as a separate compound, instead of CH2, if it is CH3, I would have named this as 2-methyl propane. But here, this is attached to this parent chain. So I have to call this as 2-methyl propyl. It's not propane. Now this is not a complete alkane, it is an alkyl part. So 2-methyl propyl. So see, 2, 3 dimethyl, 6, and in brackets you put the name of this substituent, 2-methyl propyl, then close the bracket and write the root word, decane. So the IUPAC name of this compound is 2,3-dimethyl 6 bracket 2-methyl propyl bracket decane. Now let's try one more compound. Now look at this compound. If I choose this as the parent chain, this is the substituent, and now this is not a simple substituent, it is a complex substituent. So if I start numbering from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have 9 carbon atoms, the root word is non, and since this is an alkane, ane should be added. So nonane is the parent chain's name. Now 1, 2, 3, 4, fifth position, I have a substituent. I told you to name this substituent, you have to start numbering from this carbon. So 1, 2, 3, same rules. When you start numbering, before that you have to choose the longest chain. So here we have chosen this as the longest chain. You could have chosen this also as the longest chain, because this way also you are getting 3 carbon atoms in the parent chain and this as the substituent. If you are choosing this way, this is the parent chain with three carbon atoms and this is the substituent. So here, what is the first step? You have to choose the longest chain. So longest chain is possibly having 3 carbon atoms. So either ways you can go this way, this way, this way, or straight. So 1, 2, 3. So 3 carbon atoms, and in the second position I have 2 methyl group. So forget this. Now name this. 3 carbon atoms, propane, and the second position 2 methyl groups. So 2, 2 dimethyl propane. I told you it's not propane, it is actually an alkyl group, so propyl. So what is the name of this alkyl part? 2, 2 dimethyl propyl. And this is attached to which carbon atom of the parent chain? 5th carbon atom. So 5 hyphen bracket name of this substituent, 2, 2 dimethyl propyl, close the bracket and then write the name of the parent chain, nonane. So follow the same set of rules that you follow to name an organic compound, to name this substituent also. Choose the longest chain, number it in such a way the substituents get the least position, and then give the name. Let's see one more example. Look at this compound. So I can choose this as the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. If I try this way, 1, 2, 3, 4, 5, 6, 7, 8, 9 only. 9, 10. So this way also I can go. If you have 2 or 3 options of choosing the parent chain, because whichever way you count, you're getting 10 carbon atoms. Then you have to go with the substituents. When you choose the parent chain, choose that chain which has more number of substituents. Now if I choose this chain as the parent chain, see this is the parent chain, then I have one substituent here, CH2, CH3, and I have one more substituent here, a complex substituent. I get just 2 substituents. Suppose if I choose this as the parent chain, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. If I choose this as the parent chain, I am getting 3 substituents. See, 2 substituents here and 1 complex substituent here. So then which should be chosen as the parent chain? This is chosen as the parent chain, not this. Because if this is chosen, I'm getting only 2 substituents. If this is chosen, I'm getting 3 substituents. So this is preferred. So I'm starting the numbering from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 decane. In the third position, I have 2 methyl groups. So what should I say? 3, 3 dimethyl. Keep it as such. We are not yet decided. Now we have to name the complex part. This is the complex part. I told you, you have to start one from that carbon of the substituent which is attached to the parent chain. So this carbon is attached to the parent chain. So you are starting the numbering from here. So you have to choose the longest chain. 1, 2, 3, 4. This is the longest chain, or 1, 2, 3, 4. Either ways you are getting ethyl as the substituent. So we are preferring this. 1, 2, 3, 4. In the second position I have ethyl group. So I have 4 carbon atoms, butane. So second carbon atom, ethyl. So I can say 2 ethyl butane, and not butane. I told you it's butyl. Since it is treated as the substituent, it is an alkyl group. So it's not an alkane. So 2 ethyl butyl. So already we have 2 methyl groups. Methyl is M, ethyl butyl, it starts with E. So which should come first? E should come first. So while deciding on the alphabetical order, the first letter of the complete name of the complex substituent is taken. So if this is the complete name of this complex substituent, what is the first letter? E, and then compare with this M. Here also you should not take into consideration di. Here also if you have di or tetra, that should not be taken into consideration for deciding the alphabetical order. So we are just looking at E and M. So E should come first. So this complex substituent is on the which carbon of the parent chain? 1, 2, 3, 4, 5. Fifth carbon. So 5 hyphen bracket 2 ethyl butyl, close the bracket, hyphen 3, 3 dimethyl decane. This is the IUPAC name of this compound. So totally we have seen a different set of rules, nearly 7 rules to name a branched alkane. So now recall all the rules that we have learned so far. Now we will try to give the IUPAC name of few compounds following all the rules that we have learned so far. So here I have written some 6 organic compounds. Now we are going to try naming these compounds following the IUPAC nomenclature. So recall all the rules that we have learned so far. So just to begin with, remember, choose the parent chain, and that chain which has more number of carbon atoms, and it should be continuous, and number the parent chain in such a way that the substituents get the least position. So that's the basic rule, and while numbering you have to follow the lowest set of locants for the substituents. They should get the least positions. So let's try to name these compounds. Look at the first compound, CH3, CH, CH, CH3, and here you have a substituent C2H5, and again you have a substituent here C2H5. Usually what children will do, they'll choose this as the parent chain and treat these two as the substituent. That's not right. See, 1, 2, 3, 4 carbon atoms. When you start from here, you have 1, 2 carbon atoms here. So 1, 2, 3, 4, 5. If you go this way, 1, 2, 3, 4, 5, 6. Now this is the longest chain. This actually is CH2, CH3. This also CH2, CH3. So when you start from here, 1, 2, 3, 4, 5, 6. 6 carbon atoms are there. So this is chosen as the parent chain. So here and here you have 2 substituents, methyl groups. So now let's number from here, 1, 2, 3, 4, 5, 6. So in the third position and in the fourth position, I have methyl groups. So I can call this as 3, 4 dimethyl hexane, because 6 carbon atoms, hexane. So the IUPAC name of this compound is 3, 4 dimethyl hexane. I've written the names here. And coming to the next compound, see, let me try this as the parent chain. 1, 2, 3, 4, 5. 5 carbon atoms. If I start from here, 1, 2, 3, 4. 1, 2, 3, 4. So obviously this is going to be your parent chain. In the third position, I have 2 methyl groups. So 3, 3 dimethyl, 5 carbon atoms, pentane. So 3, 3 dimethyl pentane is the IUPAC name. Suppose a compound is given like this, bond line structure, instead of this expanded form. So I told you the corners, they are CH3, 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 and this is also CH3. So in the middle it is CH2. This is CH2, CH2. Here it is CH, because in that CH2 a hydrogen is removed and a substituent CH3 is put. So choose the longest chain. 1, 2, 3, 4, 1, 2, 3, 4, 5. So 5 carbon atoms. This is the longest chain. So 1, 2, 3. In the second position, I have what? A methyl group. So, sorry, third position. 1, 2, 3, 4, 5. So 3-methyl pentane is the IUPAC name. Why pentane? Because 5 carbon atoms in the parent chain. In the third position, we have methyl. So 3-methyl pentane is the IUPAC name. Now coming to this example, we have again bond line structure. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. So this is chosen as the parent chain. So in the second carbon, we have a line. I told you if just a line is given, then that is methyl group. Here also we have a methyl group. Suppose if you have a line and if it is bent, then that is ethyl. CH2, CH3. So a line and again a bent, then that would be ethyl group. Here it is methyl. So 7 carbon atoms, heptane. In the second position, 1, 2, 3, 4, 5. And in fifth position, we have methyl groups. So what should you name this? 2, 5, dimethyl. Dimethyl. 7 carbon atoms, heptane. So 2,5 dimethyl heptane is the name. Now coming to the fifth compound. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms, again heptane. See, 1, 2, 3, 4, 5, 6, 7. In the third position, we have 2 lines, which means 2 CH3 groups, methyl groups, attached to the third carbon atom. So how can you name this? 3,3 dimethyl heptane. 7 carbon atoms. So first choose the parent chain and then number it in such a way that the substituents get the least position. If you number from this side 1, 2, 3, 4, 5, substituents will get 5th position. So that's not right. So numbering from this side is proper. Now the 6th compound, CH3, CH3, CH2, C, CH3, CH3, CH3. Now let's choose this as the parent chain. 1, 2, 3, 4, 5. 5 carbon atoms. If you try in some other ways, 1, 2, 3, 4, 5. There also you're getting 5 carbon atoms. So in both the ways you're getting the same substituent. So no matter whichever is chosen as the parent chain. So I'm going with this. So this is the parent chain and I have 5 carbon atoms in the parent chain. So the root word would be pent. So as we are talking about alkanes, we have to add the suffix ane. So pentane. Now 1, 2, 3, 4. In second position, a methyl group. Fourth position, 2 methyl groups. So 2, 2, 4 is the set of locant. If I number from this side. Suppose if I am numbering from this side, 1, 2, 3, 4. 2, 2. Here also 2, 2, 4. So both the ways I am getting the same set of locants. So no matter how you count, no, you're not getting the same number. If I'm counting from this way, 1, 2, 3, 4. So 2, 4, 4. If I count this way, 2, 2, 4. So 2, 2, 4 is preferred because I told you have to compare each number with the other number in the set of locants and it is compared term by term till the first point of difference is reached. So the one with the lower number is chosen. So if I number from this way, I'll get 2, 4, 4. This way I'll get 2, 2, 4. So first number would be same. Second number, in one set of locant I'll get 2. The other set I'll get 4. So I have to prefer the lowest one, 2. So I'm preferring the numbering from this side. 1, 2, 3, 4, 5. So 2, 2, 4 trimethyl. 3 methyl groups. 2, 2. Why I'm telling that twice? Because the same carbon atom, which is the second carbon atom, 2 methyl groups are attached. So 2, 2 and again 4 because all the 3 are same and mention this position also 4 trimethyl and 5 carbon atoms pent. So pentane 2, 2, 4 trimethyl pentane is the IUPAC name. Now coming to this example, say I have CH2, here CH3, CH, CH3, CH, CH3, CH3. Now I have to choose the longest chain. I can start from here 1, 2, 3, 4, 5. See, this is CH3, this is CH2. If it is bent, don't think this is a substituent. You can start from here itself. 1, 2, 3, 4, 5. So 5 carbon atoms pentane. If I start from here 1, 2, In second position, I have a methyl group. In the third position, a methyl group. So 2,3 dimethyl pentane is the IUPAC name. So remember all the rules and go step by step while naming an organic compound, especially while numbering and naming the substituents. You have to be very careful and abide by the rules. So this is how we name branched chain alkanes. In the next video, we will see a few more compounds, like compounds with cyclic structures and compounds containing functional groups and how to name them. Thank you.